Okay, so for the first section here, we have section 1.1. It deals with numbers, variables, and expressions. So that's the title or the objective of this section. And so in mathematics or in any field, you have to have a um, some axioms. So basically, um, terms or things that you agree on that, one is equal to one, it's not equal to three or five. Okay. So they're just basically truths or axioms that you all agree on so that you can be on the same page. So some of these axioms or this vocabulary that we have in the first section are these terms. Okay. Natural numbers. Does anybody remember what natural numbers are or what do they start with? Again, try to refrain from using AI. Try to see if you coming from your mind, what you remember. Good, right? So natural numbers start with one. Sometimes they're called counting numbers. Okay, so you have one, two. Let me use a different color here. All right, so you have one, two, three, four, dot, 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 etc. Right? The dot, dot means it goes on forever. Correct? Okay, what about whole numbers? What does that start with? Good. Zero, right? Whole numbers. I think of the word whole, right? So it starts with zero, one, two, three, etc. Okay. All right. What about integer numbers? What are those? What are integer numbers? Okay. Yeah, so integer numbers, they're not dealing with no decimals. Okay, so that's like it's like the number line. Okay. So, you can have -2, -1, 0, 1, 2, 3, etc. Right? Goes on forever and then goes on forever on the negative direction. But again, there's no decimal points, no fractions or things like that. Okay. Those are just your regular integer numbers. Okay. All right. Product or factor. So when they're talking about that, so for example, if we have 42, right? Um, the product of 42, right, is going to be what, like 6 times 7, right? So 6 times 7, those are going to be your factors, right? These are called your factors, okay? And then, of course, 42, that will be your product. So this is the result of that. But sometimes product also means multiplication, okay? To multiply. But the product, the result, right, will be 42. Okay, and then of course this dot here in the middle, right, that means to multiply. All right, sometimes it'll just be six times x. But sometimes we refrain from using this x because sometimes that means a variable. So we use a dot in the middle to indicate that we're multiplying two numbers. Okay. All right, what about prime versus composite? Name me some prime numbers. What are they? All right, so it's going to be bigger than one, all right? So by definition, one is not a prime number, all right? So it has to be bigger than one. So some of them, as you have listed here, for prime will be 2, 3, 5, 7. So it's one and itself, okay? So one in itself. So one times two, one times three, one times five, one times seven. Okay, so and etc. Okay, there's a lot of prime numbers. So what about composite? What does that mean? multiple parts. Okay. Can you expand further? All right, so give me some examples of composite numbers. Can be divided many different ways evenly. Okay, good. All right, so okay. So one example can be say 8, right? Or 12 or 10, right? So those are different composite numbers, right? So in this case, we can have multiple products that will give us 8, right? So we can have 1, 8. We can have say 2, 4. All right. So again, it's just not just the number one in itself, it's multiple factors that can produce 8. Okay. So again, so 8 is a composite number, such as also 10 or 12. Okay. What about 13? Would 13 be a composite number? No, right? Because again, you can only do 1 and 13. Okay. And you need more than that. Okay. So this 13 is a prime number. Okay. All right. Any questions so far? Okay, so let's talk a little bit about prime factorization. And so basically what you're going to be doing is you're going to be breaking it down into primes. All right. Okay, let me pause here for a second. All right, so the next term here, vocabulary, is prime factorization. So basically you want to break it down into its primes. All right, so for example, let's work on 60. Okay, so if I have 60 here, let me use a different color. Let me do it. Yeah, let's just do this way. Okay, so if I have 60, all right, of course I can choose say 1 and 60. Those are two factors that will give me 60. Okay. Another set of factors that I can multiply by and give me 60 is say 4 and 15. All right. So those are again two factors that will result into 60. However, are they in prime factorization form? No, because 4 is not a prime number and 15 is not a prime number. So that means I need to break it down further. So if I broke it down to say, I can say 1 and 4, but again, that's not going to help me because again, I need to break it down to its prime form. So if I choose 2 and 2, right? 2, as we mentioned, is a prime number. So that's going to be in its prime form. 2 times 2 will give me 4. And then for 15, right, I can also break it down to 3 and 5. Okay. So, and we know 3 is a prime number and 5 is also a prime number, right? Because it cannot be divided into anything else. Okay. Besides itself and the number. So in this case, I've broken down 60 into its prime factorization form, which is going to be 2 times 2 times 3 times 5. So if I again multiply all of this, that will give me 60. But in prime factorization form, it would be these numbers here. Does that make sense? All right, so that's what that means. Prime factorization is breaking it down into its prime. Okay, prime numbers.
I have a quick
And when
question.
you multiply those prime numbers, the result is going to be 60. Go ahead.
Yes. Okay. So it makes sense. So like pretty much whatever your product is, you're just trying to break it down till you can't break it down no more to find the
Exactly.
prime. Okay. Noted. Got you.
Exactly. All right. Any others?
I have a really quick question. What does
Sure.
the MUH stand for? That's above the dot.
About God. Oh, right here, multiplication. That says multiplication. This right here, multiply. That's a dot, means multiply. Sure, no problem. Okay, so I just mentioned that in order for us to do prime factorization, it has to be a composite number versus if we have 89, it's a prime number, and so we get stuck. And 189 is the only two numbers or two factors that will give us 89, and we can't go any further. Okay, so in order to do the prime factorization, it has to be some composite number. Okay, or in this case, in 89, our answer would just be 1 in 89. Okay. All right. Next part here is variable, right? So in mathematics, they are intentional about the variables that they pick. So mostly like say for geometry or something like that. Um, so for example, um, if I have say x, lowercase y, lowercase z. Okay, if these are lowercase, all right, a lot of times they're the output of a formula. Okay, so for example, if I have the area, okay, it would be represented by say base times height, but it'll be a lowercase, so b, times h, right? So those are lowercase ones. Okay. Um, Now, if it's a capitalized, so it's an uppercase, so I can also represent this as A as equal to as B times H. Okay. So if it's an uppercase, it's representing, hey, the outcome of something. All right. So in this case, we're talking about the area. So another example, let's say is volume, right? So I can represent that as writing it out volume, or I can say capital V. Okay. And if you want to find the volume of the box, that would be what? Lowercase l, lowercase w, lowercase h. Okay. So length times width times height. Okay. So again, what I'm saying is, um, in regards to say finding an area or volume, these types of formulas, the output is in lowercase, and then or the things you're being multiplier in lowercase. And then when it's capitalized, it's referring to um, what you're trying to talk about. So in this case, the area is represented by A, the volume is represented by capital V. Okay. So anyway, so a lot of times they distinguish it that way. So um, it's rare to see that V is capital L times W times H or something like that. Sometimes it is written that way, but to make it a little bit more clear, um, they have these guys in lowercase and then this one in uppercase. Okay. All right. Let's have a couple more here. All right. This one is probably a hot topic one, and the difference between um, expression versus an equation. Okay. So what's the difference between an expression and an equation? All right, so an expression, well, the difference is an equation has an equal sign. Okay, so for example, 3x plus 1 equals 5, right? It has the equal sign that makes it an equation. An expression would be something like, say, 3x plus 1, all right, or 5x, or 2x squared plus 4, right? So these are expressions. or maybe just 15y. I mean 15x, or 7zyr. Right? So those are examples of expressions. Okay. So that again, the difference between an expression and equation is when you put an equal sign there, that is an equation. That means you solve for something. Okay, you solve for that variable. All right. And then the other vocabulary here are formulas, right? So there, as you know in math, there are many types of formulas, and probably the most famous one is y equals mx plus b, right? Which is the slope intercept form. Okay. All right. Okay, so this next part here, what we want to do is we want to classify, all right, we want to classify the number. Okay, so we can write it as, classify as prime, composite, or neither. Okay, so let me write these down. So 36, 0, 13, and 900. All right, so again, an expression, I'm not solving anything. I'm maybe rewriting in a way where I can reduce something. So for example, if I had 15x, y, z, and it's divided into say 3x, all right, then I can reduce this. This is an expression still. I'm not solving for a particular variable, right? The 15 divided by 3 will give me 5, and then the x's here will cancel, okay? And then I have 5, and this will equal 5yz, all right? So this here is still an expression, all right? It's still an expression. I'm not particularly solving for what is the value of y, what is the value of z, okay? So once I start doing that, right, when I have the equal sign there, then I need to figure out, okay, what does this x mean, all right? All right, so that's the difference between them. I'm looking for equation, I'm looking for a value that I plug in for x that will give me a 5. For this one, I'm just simplifying it, okay? Rewriting it in a way that it's reduced in this case, okay? All right, so for each and every one of these, we need to identify whether it's prime, composite, or neither. Okay, so um, so for example, we already mentioned 13, right? 13 is not a composite number because the only two numbers you can multiply to give you 13 are 1 and 13, right? So 13 is a prime number, all right? Now, for 0, right? 0 is kind of the neutral zone. So it's neither prime or composite. But one of the definitions of a composite is that it's a limited amount of terms you can divide the number by. But for it to get 0, there's infinite, right? 0 divided by 1 is 0. 0 divided by 2 is 0. 0 divided by 3 is 0. So there's an infinite amount of numbers you can divide by 0 to get 0. So that's one of the reasons why it's not um, a composite number. And of course, it's not a prime number because, again, a prime number has to be bigger than 1, right? Cannot be 1, has to be bigger than 1. All right, so 0 here is going to be neither. So I'll put that N for neither. So that means 36 is a composite number and 900 is a composite number. Now, what do we know about 36? What kind of number is that besides being a composite number? Can you think of what else it satisfies 36 as? Now, before we talk about that, let's go ahead and break this down, right? We have 36. It's a composite number, okay? And then so we can do 1 and 36, but again, that's not going to help us. So we choose a different pair, 6 and 6, all right? And then we can break down 6 and 6 as 2 and 3 and 2 and 3, right? So these numbers here, all right, they're all prime numbers. All right, so that's 2 times 2. You don't have to put them in order, but 2 times 3 times 2 times 3, right? That will give us 36. So this here would be in prime factorization form. Okay? All right. All right. What about 900? Now, before I talk about 900, um, let's talk a little bit about 36. Okay? Let me pause here. So 900 is a big number. So what I recommend is breaking it up in these particular numbers. Um, and it deals with what's called um, perfect squares. What is a perfect square? Anybody remember? What's a perfect square?
Isn't it like basically when like how 36 was with 6 times 6, where it's like
Exactly.
it's the same numbers like multiplied?
Exactly. You're right, right? So 6 times 6 will give me 36. What's another perfect square?
900 is.
Not a perfect square.
Oh, okay.
It entails, well, let me see. Is 900 perfect square?
It's 30 times 30, isn't it?
Yeah, you're right. It is. All right. Oops. Okay, what else?
25.
25. Okay, so that would be what? 5 times 5, right? 5 times 5 is 25. Okay. 4 times 4 is 16.
Nine times
3
nine
times,
would be
huh?
81.
Exactly, right? So 3 times 3 is 9, so on and so forth. Okay. 1 times 1 is 1. 2 times 2 is 4. Okay. So those are perfect squares. So if we literally draw it out, this is a 1 by 1. And then if we break that down, this is a 2 by 2. Okay. This is a 3 by 3. Right. So 3 times 3 is 9. 2 times 2 is 4. 1 times 1 is 1. All right. So basically any number itself is a perfect square. And so you have infinite amount of perfect squares. So if I know that, that's one way. So if I have 900, okay, if I break it down to perfect squares, okay, so 9 is a perfect square. We mentioned that. Okay. Another perfect square is what? 100, right? 100 is what? 10 times 10. This is 100. So if I break this down to 9 times 100, that gives me 900. Then what do we know about 9? Well, 9, I can break that down as 3 times 3. And then for 100, I can break that down as 10 times 10, correct? Or I can break it down to 2 times 5 and then 2 times 5. So now I have it in prime factorization form where we have 3 times 3, 2 times 5 times 2 times 5. Okay, so that's one way. Again, there's a lot of ways of doing it, whatever works with your brain, but this is one way. Is okay, how can I break it up that it's two perfect squares? All right, okay. Now, if that again, it's not jiving, with your brain, then you can start just breaking it down by twos. So do 900 divided by 2, and then just keep breaking it down. Okay. So 900 divided by 2 will give me 450. Okay, then I can break that down. So 450 divided by 2, right? That gives me 225. I can't break down 225 by 2, but I can do it by 5s now. Okay, so 225 divided by 5. Okay, that gives me 45. All right, so on and so forth. Okay, so um, whatever works with your brain. Okay, so in this next part of the section is talking about evaluating the expression. So notice again here, it tells you what x is equal to, but these on the left side, these are all expressions, right? They're not equal to a particular another item. Okay, so these are all expressions on the left side, right? So all we're doing is evaluating this, and they're telling us what to plug in for. Okay, so for example, for the first one here, we have what? 5 divided by x minus 3, and they tell us that x is equal to 8. All right, so that's not a problem. So I can just plug in, right? Evaluate means I need to plug in my information to get my result. So I get 5 divided by x is what? 8 minus 3, right? On the 5, there's nothing I can do up there, so I can just leave that alone. And then for 8 minus 3, well, that gives me 5. Well, what do we know about 5 divided by 5? Well, I can reduce this expression to what? 1, right? Because 5 divided by 5 is equal to 1. All right, so I just evaluated the expression. Okay. All right, so why don't you guys try the next 3 here? All right, so for the next one we have, it tells us x is equal to 2, so we're going to plug that in, right? So that's going to be 3 minus, and then 6 divided by 2, right? So we do what's inside the parentheses first. So 6 divided by 2 is going to give us 3. So 3 minus 3 will give us 0. So the answer for the second one is 0. All right, the next one here, again, we're just plugging this information that tells us x is equal to 8, all right, and then y is equal to 4. So again, this expression here, 8 divided by 4, it just reduces to 2. Okay, which a lot of you guys got. And then the last one here, we have y times x minus 4. So y is 3, and then x minus 4. So that's going to give us 5 minus 4. Okay. So remember, and anytime you're trying to simplify anything, you always remember PEMDAS, right? So please excuse my dear Aunt Sally, right? And I'll talk more about this later. But so remember, you always focus on the parentheses first, then the exponents. And then I kind of put these guys on the same level. So of course the multiplication division will trump the addition and subtraction. But whatever comes first from left to right regarding the multiplication division, and the same thing for adding and subtraction, whatever comes first from left to right. Okay. So but the key part here is that we focus on inside the parentheses first, and then what we do it is then we focus on the exponent next. All right, so in this case, I'm going to focus on inside the parentheses here because that's the first line of step we have to do, or the first step we have to do. So 5 minus 4 will give us 1. Oops. And then 3 times 1 will give us 3. Okay, which again, many of you guys got. So that's our answer there. All right, so we want to translate the phrase, okay, to an algebraic expression. All right, so here it says 5 more than a number. Okay, so in this case, 5 more than a number is talking about adding 2 things. But when you see this, the way it's written this way, a lot of times you might think, well, is this just going to be 5 plus x? In technical terms, actually, it's going to be the other way around. So 5 more than a number is translated as x plus 5. Okay? 5 more than the number is translated this way. Okay? I know we're tempted to put 5 plus x. It doesn't matter what variable you pick. You can pick x, you can pick y, you can pick whatever variable you want. It doesn't matter. Okay? Um, but anyway, but when you see it this form, when it says more than, actually it's going to be the variable plus that number. Okay? All right, the second one here, twice the cost of a gallon of gasoline, right? So that's just going to be what? Twice, it means double the cost of a gallon of gasoline. Well, I don't know what that is, so that's just going to be represented as, so that's just be represented as G. So twice the cost of a gallon of gasoline, and I have 2 here. So the answer here will just be 2G. Okay. The next one is the quotient of 2 numbers. What does quotient mean? What does that mean again? Quotient? That means to divide, right? Okay. So quotient means to divide. So the quotient of 2 numbers. I don't know what those numbers are. Okay, so again, but I can pick any letter I want. I can pick A, I can pick B, I can pick X, I can pick whatever letter. So the quotient of 2 numbers means 2 numbers are being divided. So X divided by Y. Or I can say A divided by B. It doesn't matter. Okay, all right. Okay, so next one, it says 200 less than the population of a town. So again, the more than, you see the more than we have flipped it, we're going to do the same thing for this one. When it says less than, we're going to flip it as well. So we're going to have the 200, right? So this is 200 is represented by this. And then less than the population of a town, right? We can again pick any variable that we want. All right, so we can say P or X, whatever you want. And then less than means minus to subtract. But again, but if we see less than, it's actually flipped. So 200 less than the population of town is written as P minus 200. Okay. So anytime you see the less than or the more than, you flip them. All right, and then the last one here, I'm out of time. 1/4 of a number increased by 1/10 of a different number. So 1/4 of a number, so it'll be 1/4. Again, doesn't matter what letter you pick. Let's say X or R, it doesn't matter. So 1/4 of a number, and then increased means to add, right? Increase means to add, and then 1/10 of a different number. So 1/10 of a different number. So it can't be X, so we can say we can pick Y or R or whatever letter you want. All right, so this will be 1/4 of a number increased by 1/10 of a number. And then that will be your answer there. So again, don't forget to circle your answers. All right, let me pause there.